So welcome to all for the course of refrigeration and air conditioning. So in previous class we have discussed the introduction definitions of refrigeration and air conditioning. We have discussed artificial refrigeration and natural refrigeration. Now we are moving towards the applications of refrigeration and air conditioning. So refrigeration and air conditioning have various applications. For example, refrigeration and air conditioning used to store various fruits and vegetables, then various dairy products, then applications of refrigeration in chemical and process industry, for example, for separation of gases in petrochemical plant at minus 150 degrees Celsius, then condensation of gases, for example, ammonia is condensed as minus 10 to 10 degrees Celsius to fill in cylinders or for storage. Then dehumidification of air have various applications in pharmaceutical industry and other industry. Then solidification of solute. Then storage of various liquid at low pressure and low temperature. Then removal of heat of reaction. Recovery of solvents. So these are various applications of refrigeration in chemical and process industry. Then some other applications of refrigeration in, for example, cold treatment of metals. So dimensions of precision part and gauges blocks can be stabilized by keeping it at temperature around minus 90 degrees Celsius. The hardness and wear resistance of carburized steel can be increased by this process. Then if you keep the cutting tool at minus 100 degrees Celsius for 15 minutes, it increases the life of cutting tool. Then refrigeration have various application in medical applications, then in construction industry also, then desalination of water, then ice manufacturing, then refrigeration and air conditioning have various applications, for example in industrial air conditioning. So various laboratories, so there is involved precision measurement to performance testing of material, equipment and processes at controlled temperature and relative humidity. For example, laboratories carrying out research in electronic and biotechnology require clean area, clean atmosphere. Then air conditioning have applications in printing industry, then manufacturing of precision part, textile industry, pharmaceutical industry, photographic material, then farming of animal, computer rooms, power plant, vehicle air conditioning and comfort air conditioning. So tremendous amount of applications available for refrigeration and air conditioning. Now in our syllabus, we are going to study various applications like domestic air conditioner, domestic refrigerator, automotive air conditioner, evaporative coolers, water coolers, then commercial refrigeration in dairy, cold storage and ice plant, then commercial air conditioning in multiplex and hospitals. So one by one we are going to cover the various applications of refrigeration and air conditioning. Now before that, you must know the basic cycle of refrigeration and air conditioning, that is what vapor compression refrigeration system. So any vapor compression refrigeration system consists of these main component like compressor, condenser, expansion valve and evaporator. So function of compressor is to compress the refrigerant from low pressure to high pressure. So compressor sucks the refrigerant vapor. तो इस लाइन में जो फ्लो होता है रेफ्रिजरेंट जो गैस फ्लो होता है इस लाइन में से इन सर्किट में से दैट इज कॉल्ड एज रेफ्रिजरेंट. So refrigerant coming from evaporator to compressor, it is in vapor form and at low pressure. So function of compressor is to suck the low pressure refrigerant vapor and compress to high pressure that refrigerant. So compressor compressing the refrigerant from low pressure to high pressure. So at the output we get the refrigerant vapor at high pressure and high temperature. So that high pressure, high temperature refrigerant vapor will enter into this condenser. So condenser cools that refrigerant vapor. So condenser condenses that. So condenser, there is rejection of heat to the atmosphere by the refrigerant. So in condenser refrigerant loses the heat to atmosphere. So in condenser refrigerant loses the heat to atmosphere so that the refrigerant will get converted into liquid form, and that liquid refrigerant at high pressure again sent to expansion wall. So expansion wall is nothing but, example is capillary tube, have very small cross section area. So as the refrigerant pass through this capillary tube having very small cross section area, the temperature and pressure of the refrigerant get reduces, part of the refrigerant get vaporized, and that refrigerant which is in liquid condition at low pressure, it will send to evaporator. So in evaporator what happen? The refrigerant which is in liquid form, it will absorb the heat from the surrounding space. So in evaporator refrigerant is absorbing the heat. So as refrigerant absorbing the heat, it will get vaporized. It means that refrigerant get absorbing the latent heat so that it will cool the surrounding space. It will get vaporized, and that refrigerant which is get vaporized, which is at low pressure, again sent to the compressor, and the cycle get continued. So this is called as basic vapor compression system. And now we are going to, so any active refrigeration and air conditioning system uses this basic component. Now in next video we are going to discuss various applications of refrigeration and air conditioning. So thank you for listening.